Hello, my name is Pascal Overov. In today's Zero2Hero video, we're going to talk about constraint tags and placement decisions in VMware Cloud Assembly. We're going to discuss how the provisioning engine makes placement decisions when we create deployments, how it makes those decisions for extensibility actions, either ABX actions or VRO workflows, how we can affect those placement decisions by using constraint tags. We're gonna take a look at best practices around capability tags, which we can assign to objects, and at the end we're gonna take a look at an interesting use case we can achieve with tagging to achieve an HADR scenario. I hope you enjoyed. Let's start. Before we speak about constraint tags and placement, let's first talk about some of the configurations that you typically do to get Cloud Assembly up and running. One of the first things you will configure are cloud accounts. These are your endpoints to public clouds or on-prem vSphere or VMC on AWS, to which you want to provision resources. Let's take one of these, for example. For my AWS cloud account, as you can see, I've also selected the regions in which I want to provision. Next, you typically configure cloud zones for each and every cloud account and the regions within that cloud account that you want to provision to. To continue the example, for each of the selected regions in my cloud account for AWS, I have created cloud zones to provision to US West 1, US East 2, and US West 2, similar to other cloud accounts like GCP, Azure, and vSphere on-prem. Similarly, I have configured network profiles again for each and every region that I want to provision to, for each and every cloud account I want to provision to. Let's open one of these network profiles to take a look what's inside. Under the Networks tab, I have added in this case, AWS networks that I want to be part of this network profile. And as you can see, I have a set of private and a set of public networks, again, for each and every availability zone within that profile's region, which is US West 2 in this case. Similarly, you will configure storage profiles, again, for each and every cloud account you want to provision to, and for each and every region you want to provision to. Let's take, for example, AWS US West 1. If I open this one, I have inside 5 storage profiles for the different types of volumes which AWS supports, to which I want to provision to. Once you have all of this set up and configured, you typically add some of these cloud zones or all cloud zones to your project, assign them priority so that you can provision to these cloud zones all your resources via blueprints. Now let's take a look at a typical blueprint example. In this example, you can see the layout of a typical 2-tier, 3-tier app, where the web tier is connected to a load balancer and to a public network. The DB tier is connected to a private network and maybe to an additional volume. And the web tier is dependent on the DB tier, which is shown by the dependency arrow on the canvas. Now let's consider the following use case. Let's say we have two or more equally valid paths for deployment, meaning we have configured, for example, an AWS cloud account with an cloud zone, let's say US West 2. We have configured an Azure cloud account with an US West 2 cloud zone, and we have configured a vSphere on-prem cloud account with a cloud zone mapping to a cluster. All these three locations are valid paths for deployment for this particular blueprint. Let's also say they have an equal priority on a project level. Let's say the AWS, Azure, and vSphere endpoints have all priority 0, which means none of them is preferred for deployment on a project level. Let's also say we don't have any constraints in our blueprint that will force our deployment to go one way or another. Where will this deployment go? To answer this question, we have to understand something which is happening during provisioning time. During provisioning time, all the objects on the canvas will be grouped together based on links. We can differentiate between three types of links between objects on our canvas. We have the so-called explicit links, or this is the solid arrow between the web tier and the DB tier, which is created by the dependent property that we have set up between these two objects. This property says that the web tier should be provisioned after the DB tier because the DB tier is dependent, because the web tier is dependent on the DB tier. We also have implicit connections on the canvas between objects, or those are the dashed arrows between, for example, the web tier and the private network, the volume and the private network, the web tier and the private network, or the application load balancer and the private network. These links are typically created when somewhere within the object you are referencing information from another object. In this case, on my volume object, for the resource group name, I'm referencing some values from the private network. This creates the implicit connection shown as dashed arrow. The third type of connection are the links represented by hard line between resources. For example, between the load balancer and the private network, between the load balancer and the web tier, between the web tier and the public network, and between the DB tier and the private network, and of course between DB tier and the volume. During provisioning time, these all objects on the canvas will be grouped based on the link connections between them. Again, link connections are represented via hard line on the canvas, which means in these particular examples, during provisioning time, two groups of objects will be created. The first group will be the web tier, load balancer, and public network. These are all connected via links, via hard lines. Let's say this is our orange group. And we can also see that furthermore, the DB tier is also connected to the private network. The DB tier is connected to the volume. And although the DB tier is not connected to the web tier, it is connected via the private network links, which means all of these objects will be grouped together because all of these in one way or another are connected via these hard links, and all of these will be placed together. Now, if we have a multiple valid paths for deployment and all of these have equal priority in our project, one of these cloud zones will be picked on a pseudo round-robin basis for the provisioning process, which means the deployment may land in AWS, it may go to Azure, or it may go to vSphere on-prem if they all had equal priority. Now let's modify this blueprint a bit and examine another use case. I'm going to delete the load balancer from the canvas. What will happen during provisioning time if we deploy the blueprint as shown now? Again, grouping will take place. This time we can see the web tier is connected to a public network. This will be one of our groups. The DB tier is connected via link to the private network and it's connected via link to volume 1. This would be our second group. Group 1, web tier and public network, are not connected in this case to group 2. They are not connected to neither the DB tier, the private network, or the volume via hard constraint in any place. Which means during provisioning times, those two groups will be grouped separately and each of them may land on a different cloud zone, again assuming we have multiple valid choice for provisioning, which means my web tier may go to AWS with the public network, but my DB tier with my volume and my private network may go to, for example, Azure or vSphere on-prem. So to recap, grouping is done only based on the hard links between objects. Explicit connections like the depend on connection here, or implicit connections like the dashed arrows here, are not considered during grouping process during provisioning time. Now, before we further discuss how we can force this deployment to go one way or another via constraints, let's first briefly discuss what constraints are and what type of tags we have in Cloud Assembly. If you're reading the official documentation, you may notice that there are two types of tags that are typically referred. You can see that we talk either about constraint tags or capability tags. These are exactly the same thing. Depending on where we use them within the UI and our blueprints, these are called either capability tags or constraint tags. Let's give an example of this. Let's say I want to describe and I want to tag one of my network profiles so that I can use that tag later on in my blueprint to force the deployment to go to this particular network profile. When I place tags on configuration objects like network profiles, networks, storages, cloud zones, or cloud accounts, these are called capability tags because these describe a particular capability that this object gives me. For example, I may add a capability tag to my network to say that this network gives me a private access, or that this network gives me a DMZ access, or that this network is a DHCP capable network, and so on. Similar, for example, for storage profiles, if I need to add capability tags to storage profiles, typically this will describe the capability a particular profile gives me. For example, this profile gives me the capability of being PCI capable. This profile gives me a silver capability, a bronze capability, or a gold capability storage. Now, later on in my blueprint, if, for example, I want to provision to a gold storage profile, I would use this same capability tag added here. I can easily copy it. I can go to one of my machine resources. I can find the storage, and under constraints, I can add this tag. When I use this exact same tag within my blueprint under constraints, either under machine constraints or machine storage constraints or network constraints, as we can see here, or constraints for a volume object, I'm constraining where this particular object can be deployed from all available options configured. And because I'm constraining it, now the tag that I use here, it's called a constraint tag. But again, this is exactly the same tag which I've used in my infrastructure, which I've attached to my storage profile. So again, if I'm describing a particular object in the interface and I'm assigning a tag to it, that tag is called capability tag. Again, for example, I have these capability tags here on account level that I can set up. When I use those exact same tags within a blueprint to constrain or force that blueprint to go one way or another during provisioning time, to use one set of resources or another, these tags are called constraint tags. Now let's see how we can use those capability tags in our blueprint to force the deployment to go to a particular resource. As you can see, for example, I have tagged all my cloud accounts with a tag saying cloud account owner Elastic Sky, which notes that this particular cloud account belongs to a particular customer or particular business unit, for example. And if I want my deployment to land on a particular cloud account that belongs to this customer, I can use this tag within the blueprint. And this is going to be my first tag that I'm going to copy and set in my blueprint. Tags which are constraint capability tags which are set on cloud account level or a cloud zone level are consumed within the blueprint on a machine resource level, which means if I go to my DB tier machine resource, I scroll down under constraints, I will delete the existing ones, I will place my cloud account tag here, which will say during provisioning time, I want my DB tier machine resource to go to a particular resource which has this tag applied. Let's take a look at my cloud zones and the tags I've configured on these. As you can see, in each and every public cloud, for example, my company considers US East 2 to be a dev region. Therefore, I have placed a tag called Cloud Zone Environment Dev to note this. Same goes for vSphere On-Prem, which is in the same US region. Same goes to Google Cloud Platform, which I consider US East 4 to be my dev region in that platform. And same goes for AWS US East 2, which I consider to be my dev environment region. All of these cloud zones have been tagged with this cloud zone and dev tag. Similar to this, I consider US West 1 to be my test environment in all public clouds, which is notated with the test tag, and I consider US West 2 to be my production region in each and every cloud account configured. Let's say I want to provision to a production cloud zone, which means I will copy this capability tag describing my production cloud zones or my cloud zones which are capable to give me this. I'll go back to my canvas, back to my machine resource, and I'll add a second tag to say not only I want to provision to a cloud account which belongs to me as a customer, for example, but I want to provision to a cloud zone within that cloud account which I consider to be production, or a cloud zone which is tagged with a cloud zone environment production constraint, a capability tag. Let's now take a look at the network profiles. As you can see, similar to this, I've tagged all my network profiles which are in US East 2 with network profile environment dev because this is my dev region. Same for Azure, same for GCP, same for vSphere on-prem. Similar to this, I have tagged with environment prod all my network profiles which are in US West 2. And test all my network profiles which are in US West 1 in each and every cloud account. Let's open our production network profile, for example, in AWS. And you can see here I have two sets of networks, private networks and public networks added for each of the availability zones in that particular region, which in this case are 3, 4, US West 2. For each and every one of these networks, I've also added a tag to note the capability this network gives me. For example, these 3 networks give me the capability of being public, being private. Therefore, I've added a tag network type private. Same tag for all networks. Similar to this, I've added a tag network type public to all networks which give me public access to that in that particular network profile in that particular region. So let's copy those capability tags and let's use them in our blueprint to note that I want my DB tier to be connected to a private network. I'm gonna go on the network object, and again under constraints I will set up network type private, which will note I want this to connect to a private network. Similar to this, I will select the public network and I will add a tag network type public. Similar to this, if I look at my storage profiles, I can pick a particular storage profile that I want to provision to. Let's say I want my deployment to go to a storage profile tier which is silver. I will copy this constraint, this capability tag, and place it as a constraint tag on my machine resources. This time not direct under constraints, but I'll place it under storage constraints. And I'll do the same for the other machine resource. Now what will happen during provisioning time? Again, the grouping will take place, which we discussed before, where the web tier will be grouped together for deployment with the public network based on the hard links. The DB tier will be grouped together with the private network and the volume in a second group to be placed together. If you're interested in the whole list of deployment decisions through which Cloud Assembly goes through each time a deployment gets triggered, you can find it in the official documentation. I'll give you the highlights and few takeaways which are not noted there. Let's take, for example, the second group, the DB tier, the private network, and the volume. During provisioning time, a suitable placement for the machine resource will be searched based on cloud account availability, on cloud zone availability that matches the given constraints for the machine resource, which in this case are we are looking to provision to a resource that has our cloud account owner Elastic Sky tag, and also we want to provision to a resource that has cloud zone environment production. Typically, the private network and the volume will follow the design decisions made for the machine resource. Also, once a suitable machine resource placement has been found. This based on all available options and then filtered based on availability and constraints. The same is being done will be done for the volume and the private network, and for all available networks to which we can provision, only these that have this particular tag will be filtered out for deployment, and then from those only the networks which are in the same cloud account and the same region as the machine resource will be further filtered out to be selected for the provisioning process. Same with the volume. From all available storage profiles that meet our constraints coming from the volume, only those will be filtered that meet the constraint, and then further only those will be filtered which are in the same region, in the same cloud account, on the same compute as the machine resource. In other words, every object on the canvas which is connected via hard link to our machine resource try to follow its location for provisioning. Which means even if I remove my constraint tags for the network and for the storage, provisioning will still succeed just because a network and a storage will be picked again in the same zone, in the same compute, in the same region, in the same cloud account where the machine resource get provisioned. Yes, it may not be a private network because I have removed the tag. It may not be a silver storage because I have removed the constraint tag, but any available storage will do, which is in the same location as the machine resource. Now, another rule of thumb that I have is that each and every group from the deployment needs to be placed on a single location, meaning all the networks part of a grouping during provisioning need to land to a single network profile, all the storages need to land to a single network profile, and so on. What does this mean? If I change a bit my blueprint, let's say I have a web tier which is connected to two networks, a private network and a public network. During provisioning time, we can see web tier, private network and public network will be grouped together based on the hard links, and the deployment engine will try to find a single suitable location for each and every object type, meaning for the two objects from type cloud network, it will search for a single location to place them together. A single location meaning a single network profile. And if we go back to our network profiles, we can see that this is indeed the case. If I open an example 1, I can see that all the private and public networks to which I'm provisioning to are always in the same profile. And I can open another one just as an example. Here again, I have my public and private networks in the same network profile. Now, if I instead create two network profiles, place the private network in one of the network profiles, and then place the public network in the second network profile, this is no longer a single location for deployment. Therefore, this particular example will fail with an error saying something similar to no suitable location was found for placement that satisfies all requirements. So keep this in mind when you design your blueprints, that all objects from a given type which are grouped together by hard links need to land on a single location. Now, let's talk about different types of tags we can have in the blueprint. Let's say me as a developer, I have specified in my blueprint that I want to provision to a gold tier storage, because I as a developer always want the fastest storage, the fastest CPU, the most memory, and so on. Now I can add a suffix to this tag called hard, which is also the default suffix, which is auto added during provisioning time if no suffix exists, which means what will happen during provisioning time is that the deployment engine will search for a storage profile that has the tag CAS storage profile tier gold. If it doesn't find one, because this is a hard constraint, I'm explicitly saying this needs to be met, deployment will fail. If a storage profile exists with this particular tag, deployment will succeed. If I change this to soft, what will happen during provisioning time is that the deployment engine will search all storage profiles that will search all storage profiles for a profile that has the tag storage profile tier gold. If it doesn't find one, because I've said this is a soft constraint, I prefer this to be my choice, it will deploy on any available storage profile that meets the rest of the criteria for this deployment. And the third type of tag change I can do is I can say negative logic and the tag key value pair, which means during provisioning time, the deployment engine will deploy this VM, these storage disks, to any storage profile that doesn't have the tag storage profile tier gold. Now, all of these tags can be overridden on a project level from a project administrator. Let's say in my blueprint, I'm saying I want to provision to a gold tier storage, but if a project administrator goes on a project level under provisioning and says negative logic storage profile tier gold, this will override during provisioning time the tags that come from the blueprint. So even though I, as a blueprint developer, want to provision to gold tier storage and I'm using appropriate tags to do so, the project administrator may decide that this is not acceptable, maybe for the development team, so he may override such values on a project level. So even if I now provision my blueprint, it will provision to any other storage tier but gold, because this is what my project administrator has defined on a project level. Same can be done for network constraints as well. Now, my advice to you is when you design your tagging strategies, when you tag a particular object, only tag, only add tags that describe a particular capability that object gives you. For example, if I open one of my network profiles and open one of my networks, let's say I'm going to take US West 2 in AWS and open this network. I've only added tags here which describe what this network gives me. It gives me a private access. Therefore, I've added CAS network type private. And I've also, this particular network gives me a DMZ environment. It's a DMZ network within a DMZ environment. Therefore, I've also added a second tag to describe this capability, which is CAS network cap DMZ. There is no need to add tags like environment production. In this case, US 2 is my production environment, which my company considers to be production. There is no need to add tags that notate that this is a network coming from AWS, like source AWS or something like this. This is not needed at all, just because, as I said before, during provisioning type, all objects will try to follow the machine resource. So if I have provisioned a machine resource in AWS in US West 2, for the networks, I only need to say, for example, I want to provision to a private network. I don't need to specify furthermore tags to say private network, but also network which is AWS network, but also network which is in US West 2, or so on or so on. All these tags are useless and just add complexity to your environment. I often see people adding, for example, tags like env production to notate that this is a production object. They will add this tag on the network. They will then go add it to the network profile. They will add it to the cloud zone as well. They'll add it to the storage. They'll add it to the cloud account. The same tag. This is not a good strategy because this doesn't describe a capability this particular object gives you, and it's very difficult to troubleshoot once you get an error saying that environment prod tag doesn't meet any requirements, any doesn't find any targets for deployment. Therefore, when you add tags to objects, stick only to tags that describe what this object gives you. Don't add anything else that you may typically add to connect this object to another object, right? So for example, I don't need to add tag here on my cloud account, which is AWS, and on my AWS cloud zones to tie them together. I don't need to add a tag saying this is from type AWS, like I've done here. This is on purpose to show bad example. I don't need this second tag to say this is an AWS network to map it to an AWS cloud account. Cloud Assembly already knows that. It knows that those networks belong to AWS. It knows that those zones belong to AWS. It knows in which regions they belong to, and so on. So just stick to tags which describe a particular capability the object gives you. Typically, you won't need more than 4 or 5 tags in total in your blueprint to achieve any any use case one can think of. Now, as I said, during provisioning, among other things, all objects or cloud zones are being filtered based on the constraint tags in your blueprint, and if there are multiple cloud zones that match your constraint tags, the one with higher priority will be picked for deployment. So for example, if I have constraints in my blueprint that match both Azure US East 2 as a deployment option and Azure US West 1, for example, Azure US East 2 will be picked for the deployment because it has a higher priority on a project level. Up till now, we have been only talking about the design decisions being made for deployments and how we can affect those based on constraints. It is time to take a look at how we can affect extensibility, ABX actions, or VRO workflows which may have been attached to a particular deployment. Similar to how we could affect deployments based on constraints within our blueprints, we can affect where a particular VRO workflow will run or ABX action will run with extensibility constraints. These extensibility constraints can only be set on a project level. So if I open my project, I can see a field here called extensibility constraints. So for example, if I have subscribed a VRO workflow to run as part of the deployment process, the deployment lifecycle of particular blueprint, I can affect where that workflow may run. In this case, for example, I have 3 VRO integrations, VRO A on-prem, VRO A running in VMware Cloud on AWS, and VRO B on-prem. Now, if I want to say that for all deployments coming to my project, I want to use, let's say, VRO B on-prem, I can assign it capability tag, which I have done, called integrations ID on-prem B, and I can take this tag and I can set it on a project level under extensibility tags. Now all workflows which are subscribed to blueprints, which I provisioned from this project, will be run on that particular VRO instance. If I don't specify an extensibility constraint here, let's see what is going to happen. I'm gonna take an example workflow and I'm gonna create or start creating a subscription. I'm gonna select one of my workflows, custom workflows. Let's say this one. On the right side, you can see that Cloud Assembly has determined and found this workflow with its particular workflow ID on 2 integrations. If I create a subscription to an event for that project, if I deploy a blueprint from that project and I have not specified extensibility constraints on a project level, the workflow will run on one of these two integrations on a round-robin principle. If I want to run this only on one particular VRO from these two, like I showed you before, I will add an extensibility constraint tag on a project level to select which workflow I want to run, on which VRO I want to run that particular workflow. In the same fashion, this works exactly the same for ABX actions. If I place an extensibility constraint on a project level, all ABX actions will be affected by that constraint and will try to run on a target that matches that constraint. If there is no extensibility constraint on a project level, whichever function as a service provider we have selected within our action will be used to run the action. So if I have selected AWS here, this will run in one of my AWS regions coming from my AWS Cloud account in Cloud Assembly. Let's consider another interesting use case. Let's say I have different cloud accounts, for example, vSphere on-prem and vSphere running on VMC on AWS Cloud. And in each of these locations, I have a separate VRO. One VRO which is closer to the vCenter on-prem instance, and a second VRO which is installed in VMC on AWS to be closer to this particular vCenter. And I can see both of these VROs here in the integrations tab. One for my on-prem or two for my on-prem vCenter and one installed in VMC. Now, what if I want to, when I provision to my on-prem cloud account, I want to use the VRO which is installed on-prem, and what if I want to, when I provision to VMware Cloud on AWS Cloud account, I want to use the VRO for extensibility which is installed in that particular location. How do I do this? I do this by mapping the integration and the cloud account together via tag. So for example, I will open my VMC VRO. I have added a capability tag that describes that this is a VMC integration. I can copy this exact capability tag and I can go to my VMC cloud account and I can add it here. I don't need to specify this tag anywhere else, either in my blueprint or on a project level. Just by assigning the same tag to my cloud account and my VRO integration, I'm mapping them together. So during provisioning time, if I provision to VMC Cloud and there is a VRO subscription, the VRO workflow will run on any integration, VRO integration that matches this particular tag. In this case, I can map a given VRO integration to a particular cloud account. To learn more about how we use VRO integrations and cloud accounts, feel free to check out my blog post code using Vero integration in VMware vRealize Cloud Automation Services. Here you can find this information with a lot more details and a lot more use cases. At the end, I'm going to mention how we can achieve Cloud Proxy high availability or basic DR scenarios for cloud accounts if this is a requirement. Let's take a look again at the cloud accounts which I have configured. As you can see, I have a vCenter on-prem cloud account that connects to 7256 vCenter, and it's using my on-prem cloud proxy. Now, there is no way to set a highly available cloud proxy for that cloud account out of the box. But what I can do is as follows. I can create a second cloud account, which is vSphere on-prem hotspare, which points again and connects again to exactly the same vCenter server, but this time I'm using a different cloud proxy. I'm using on-prem cloud proxy 2 compared to the other cloud account which is using cloud proxy 1. Now, because for Cloud Assembly this is a separate cloud account, again I'll have to configure all the objects with exactly the same configuration and exactly the same capability tags for this cloud account. So for example, if I check my cloud zones, I can see my cloud zone for my vSphere on-prem cloud account. I have created a cloud zone for my vCenter on-prem hotspare, as I have called it, cloud account, similar with network profiles, network profile for both cloud accounts. I've used both tags on the network profile level. I've added the same networks. I've added the same tags to those networks in each of these network profiles. And I've done the same for my storage profiles. I have a storage profile for each and every one of these cloud accounts. So we end up being in the situation described here, where I have a single vCenter which I've connected via 2 proxies to 2 Cloud Assembly cloud accounts. Furthermore, I have image storage and network profiles for cloud account A, and I have configured image network and storage profiles for cloud account B. All of these are configured equally, and all of these have exactly the same capability tags assigned to them. The only different tag will be the one I'm gonna set on a cloud account. As you can see, I have set here my vCenter on-prem cloud account has a tag cloud account capability primary, and my vCenter on-prem hotspare cloud account has a tag CAS cloud account capability hotspare. What I can do now is I can take this tag, this primary tag, and I can set it on my blueprint together with all other constraint tags which I may have. And I can say this is now a soft constraint. What this will do is, and if I check on a project level, you will see that both of these cloud accounts, the on-prem hot pair zone coming from the on-prem hot pair cloud account, and the vCenter on-prem zone coming from the vCenter on-prem cloud account have equal priority. What this will do is, during provisioning time, all the rest of my constraints will be exactly the same for both set of objects. So both will be valid paths for deployment, the green path and the orange path. But then at the end, I'm using a soft constraint to say that I want to provision to cloud account constraint that has constraint A. If that cloud account is not available, because this is a soft constraint, any other available options will be selected for provisioning, which means in this case, path B will be selected to provision to the same vCenter. When I say the cloud account will not be available, I mean that Cloud Assembly periodically checks for the health of your cloud account and marks this available for deployment if it is okay. But if, for example, my proxy is not responding, my data collection will fail and this endpoint will be marked as unavailable for deployment. When this happens and I can no longer provision to that path via that proxy, via that cloud account, the second path will be selected because I'm using a soft constraint. Exactly the same use case without changing anything on your tagging or configuration strategy can be achieved to provision to a hot spare vCenter server. For example, I have vCenter A connected via proxy A to cloud account A, image storage and network profile A. I have vCenter B, my hot spare vCenter, connected to proxy B, cloud account B, image storage network profile B. All of these have again exactly the same tags as before, and I'm using exactly the same tagging strategy in my blueprint. In this case, if cloud account A or proxy A is no longer responding and I cannot provision to vCenter A because I'm using a soft constraint, this will trigger a deployment on path B, which will provision to my vCenter B cloud account. In that second example, those two cloud accounts are of course pointing to a separate vCenters. My primary vCenter, noted by the primary capability tag, and my secondary vCenter or hotspare vCenter, noted by the capability hotspare tag. If you wanna learn more about how to configure this with more details, make sure to check out my blog called Configuring HA Cloud Proxy and DR Cloud Account in Cloud Assembly. Thank you all for watching and stay tuned for more videos coming soon.